Alright, so here we go. Another set of Intus. They ask you boiling points of elements helium, neon, argon, krypton, xenon. Here you go, right there in the periodic table, the noble gases. Remember when we studied IMF, noble gases only have London forces. That's all they have. Because they don't bond to each other, so it's just like argon, neon, helium. So, since they only have London forces, they increase as you go down the periodic table because they get larger amounts of electrons and they become more polarizable. So when you start talking about differences in boiling points of the elements of noble gases, it's based on that. Here we go, a little kinetics. Remember, rate law is a mathematical relationship between concentration and rate. So what do they tell you? Well, in the first one, they tell you that they use 1.0 or 1 times 10 to the negative third. They study a reaction. Then they change it to 2 times 10 to the third. Well, if you ignore the 10 to the third, what are they doing to the concentration? It's going from 1 to 2. So all they want you to do is double M and double N. So basically, M is to the first, N is to the second. How is that going to change the rate? Well, really, all you do is plug in the numbers and use the exponents anytime you do a rate law. 2 squared, last time I checked, was 4 times 2. 8 is your correct answer. So you definitely need to know rate laws. Next one, halogens. Halogens in the periodic table are diatomic molecules. They don't conduct electricity. They're not all gases. They're not. Iodine's a solid, and they're not all odorless or colorless. Those might be harder, but you should know that they're diatomic. 61. If you want to change from a pH of 13 to a pH of 12, remember the pH scale is based on the powers of 10. So what you would have to do to lower the pH by 10 is you would have to dilute it by 10 times. If you have your initial amount that you start out with is 100 milliliters, then you would dilute it to a volume of 1 liters, which would increase the volume by 10 times, thus changing it from a pH level of 13 to 12. Next one, which of the following represents an isomer? The definition of an isomer means same number of atoms, but arranged differently. Because this is the organic question. Well, if you look up here, I have 1 bromine, I have 3 carbons, and I have 7 hydrogens. So automatically, D is canceled out because it has more than 1 bromine. This is 4 carbons, so I cancel that. So then I'm down to either A, B, or C. Remember, bromine is attached to the N carbon. So if you're going to rearrange it differently, which an isomer represents, it can't be connected to the N carbon. Therefore, that one would just be that molecule flipped over dimensionally, so that's not an isomer. This one, the bromine, is still attached to the N carbon. The reason why this is correct is because the bromine attaches to a different carbon atom in the chain. Next one. Notice this is a weak acid, and notice there are 2 H's. There are 2 Ka values. The second Ka value is very small. So really you would go H2, C6, H6, O6 reacting with water, and you would basically produce H3O plus, it's supposed to say H3O plus H, C6, H6, O6 minus. Then H, C2, C6, oops, H6, O6 minus would react with water again, and it would also produce H3O plus C6, H6, O6 minus. Now remember when we studied acids, I always said this is a weak acid to the negative fifth. This barely happens. This is to the negative 12. This barely happens. So it's got to be one of these two things would be the least amount of species or the lowest concentration. Well, if you see H3O plus there twice, that was going to have a greater concentration. So the one with the lowest concentration is going to be the ion when you rip all the H's off. It's going to happen very little because it's to 10 to the negative 12th. So that's why E is your correct answer. Least soluble. You're applying solubility rules. Well, remember, First thing you have to do is what's always soluble. Na is always soluble, so this one is soluble in water. NO3 is always soluble, K is always soluble, NH4. So, by knowing your solubility rules, you would know that BaCO3 is insoluble or least soluble. You have to know your solubility rules. You have to know that all group 1 metals are soluble, all nitrates are soluble, and ammonium soluble. It makes that an easy question to answer. Okay, this one. When you go to do this one, remember they're asking you mg. So when you go to do it, remember molarity times liters will always get you moles. So you need moles over liters. Well, the liters, when you combine the two, are going to be 0.600 liters. Because you have 200 milliliters and 400 milliliters. So what you're going to do is you're going to take the molarity, which is, the molarity, which is 0.6. I'm going to put 0.60 right there, times the volume in liters, which 200, I'm going to change to 0.200. So my moles are going to be 0.12. So then I take 0.12 moles over 0.6 moles, divide that into that, and you're going to get 0.2. So remember, molarity is always moles over liters. We always go molarity times liters is going to give me moles. I take the new volume, which is going to be 600 because of 200 and the 400. Which of the pure substances has the highest melting point? Well, pure substance isn't a solution, it just means IMF. Remember when we did intermolecular forces, the higher the intermolecular forces, the higher the boiling point, the higher the melting point, the lower the vapor pressure. So if you look pure substances, we have to look at what we have. Remember the ranking is going to be IMF is the weakest, then you have ionic, and then you have network covalent, because we don't really use metallic in AP chemistry on the exam anyway. So the first thing is the weakest is IMF. So anything that is intermolecular forces are all nonmetals. I'm going to cross out E. That's only London. This is polar, but still it's IMF. Intermolecular forces because it's a nonmetal intermolecular forces. Remember that SiO2 is one of the network covalent examples they always use on the exam. So therefore, network covalent has the highest strength. There are no ionic compounds, so we don't have to worry about that. So really, you have to identify the network covalent in that one. Next one. I ask you which of the following is true for any substance undergoing the process. It's a phase change. It's going from a solid to a liquid. Anytime you're going through a phase change, delta G is equal to 0. So if you take going home to supper and you set delta G equal to 0, when delta G is equal to 0, you rearrange this algebraically, and you're going to get delta H is equal to T delta S. So delta G is always 0 for any phase change. Therefore, throw 0 in here, and you're always going to have delta H is equal to equals T times delta S.